In today's video, I'm showing off this OpenGL demo involving multiple lights that cast shadows. So as you can see in our scene, we have 4 colored lights, a white, a green, a red, and a yellow one, and then we have 10 cubes and a floor, and on this floor all these lights cast their own shadows. So if we look at this one, we can see that behind this cube there's a shadow, and since it's a red light, we don't see any red here, and that's why it looks more green. And what we can do is if I push X on my keyboard, it will start moving one light up and down, and you can see how as the light moves, the shadows change. So as it's down here, there's nothing above, so it casts no shadows, but as it comes up, the shadows move in, and then they stretch as it gets closer and closer. So let's stop it there. And then the next one will start moving. So we can see up. Let's do it about there. Then the green one will move, and the green one only really casts a shadow on this one cube here. So we just gotta let it rise like that. And then the yellow one. Let's leave the yellow one there. And then the other thing we can do is if we push space, we can activate the directional light, which acts as the sun of this scene. And now you can see that all the objects also cast a shadow from the sun, including the lights. So now we can see under this cube, we have red light here, and then we got a shadow from the sun. So let's explain how this works. Down here we have 4 shaders, our regular shader for the cubes, our light shader for the 4 light sources, a directional light shader that does all the shadows from the sun, and then a point shader that does all the shadows from the lights. And then down here, this code here creates a depth map FBO, and then creates a depth map and puts it as a GL texture 2D, and we attach it to this frame buffer. And then this code down here creates 4 cube maps and 4 cube map textures, and each cube map texture is a GL texture cube map, and then we attach all 4 of those to, or 1 of each to their own frame buffer. Then when we come down here, we bind all these textures, which is a lot because we have 4 for the shadows of the light sources, one for the shadow of the sun, and then 3 just for the scene. And then down here, we first start with this light position. This just moves the light that the counter has reached up and down based on a sign of GLW get time. So that's when we push X, it moves on to the next cube. And then here, this is all the code for drawing the sun's shadow. So we set a light projection and a light view, and then a light space matrix. And in essence, what this does is it sets up a camera at the position of the light, orthographically looking down at the scene. And then we draw the scene using that with the depth map FBO, which is the frame buffer, and we bind what we drew to the texture. And then here is all the code for drawing the shadows of the cube maps, and we repeat it 4 times, 1 for each light source. And we do a similar thing, but we draw the scene from the light's perspective 6 times, and we do a perspective draw from each of the 6 directions, and then we bind each of those to the texture and bind that to the frame buffer after drawing the scene using this. And then we come down here and draw the scene regularly. And these render scene, render lights, render cube, these are just functions that, so render scene has a for loop that draws 10 cubes, render lights draws the 4 lights, render cube just creates the VAO VBO and draws the cube, render floor does the same thing but for a floor, and then calc lights sets all of these values for all the lights. So we can set how strong the directional light is, which is the sun, and we say if light follow, which is whether we push space or not, we'll either set the sun to have no diffuse value or a diffuse value of 1, which lets it turn on and off. We set all of the values from light color and light position, and then we set up the code for the spotlight that you can see here. And then in our shaders, this is our vertex shader for the cubes. It's very similar to what you see normally in my videos. However, we also take in a light space matrix and output a light space frag pause. And in our fragment video, then in our fragment shader, we take in a material, a directional light, a point light, and a spotlight. And we also take in a texture for a directional shadow and 4 textures for point shadows, and these are cube textures. Then we have 2 functions here, dir light shadow and point light shadow. So what dir light shadow does is it will use the texture that we passed in here, which is the scene drawn from the sun's perspective. And what it does is it compares the closest depth to the current depth. So what this is basically doing is that if a point on your screen, or like on the cube to be more precise, or the floor, if it can be seen from your perspective and the sun's perspective, it's drawn normally. If it can't be seen from your perspective, it's not drawn at all. And if it can be seen from your perspective, but the sun can't see it, then return shadow will be, then it will be cast into shadow. And the same thing is true for the point light shadow function. We just take in an ID so we can determine which light it is being drawn from. And if we can see the point, but the point light can't, then we return a value of 1 for shadow, or we do rounding so that the very edges are a little more smooth, but we return a value for a shadow and say we should cast that into shadow. Then in our main function, we run the calculations for the directional light, for the 4 point lights, and for the spotlight. And here's the dir light code, and we create a float shadow, which is 1 minus the dir light shadow, and we times that by the specular and diffuse. So if it is in shadow, don't give it any diffuse light or any specular light, but if it isn't, those work normally. The point light's the same thing. We take 1 minus the point light shadow, and then we times this by diffuse or specular. And then spotlight, we don't do any shadow work since it always comes from the camera's perspective, so you wouldn't be able to see anything. So if you run the code, that's what we can see, is that these shadows right here, as the white cube moves, is the fact that the white cube, if we were to pause it, or let's get it to here. If we look at if we go right to the cube, we can't actually see the shadows. So it's because we're drawing the scene like this, or this would be one side of it, that we can't see the shadows at all. But when we move our camera, we can observe the shadows because the light, what it can see, is different from what we can see. Alright, if you enjoyed this video and want to see some more, click on this video here, which is the same project but a week earlier with only the directional lights. So click there, and until next time, see ya!